Hello friends, welcome to my channel. This is Isro question paper Engineering Mechanics Part 3. A particle starts from rest with a constant acceleration alpha meter per second square, and after some time it decelerates at a uniform rate of beta meter per second square till it comes to rest. If the total time taken between two rest positions is t, the maximum velocity acquired by the particle would be how much? Given t1 t2, total time t1 plus t2 is t total time. Let it be 1 2 3. From 1 to 2 it's constant acceleration alpha meter per second square, and 2 to 3 it's deceleration beta meter per second square. So we have to calculate maximum velocity acquired by the particle. This one V max we have to calculate. So we will use formula V equal to U plus 80. So 1 to 2 if we will use final velocity is 0. It starts from rest, so initial velocity 1 at 1 is 0, U is 0, V is V max equal to acceleration is alpha, time is t1 per second, 2 into 3, V equal to U plus 80. A will be negative here because it decelerates. So V is final velocity at 3 is 0, U is V max minus beta to T2. So we'll get V max equal to beta T2. So from 1 and 2 we get here beta equal to V max by T2. T2 we already know, it's T1 T minus total time T minus T1, V max by total T minus T1. So we'll get from equation 1 T1 value we got, that value we will put here, V max by T minus T1 is V max by alpha, from equation 1 V max by alpha. So beta equal to V max into alpha divided by alpha into T minus V max. So if we solve this one, we will get beta alpha T equal to V max will take common, it's alpha plus beta. So in question it asked V max, so alpha beta T by alpha plus beta is our answer. From option alpha into beta by alpha plus beta whole into T, C is our answer. Two metallic blocks having masses in the ratio of 2:3 are made to slide down a frictionless inclined plane starting initially from rest position. When these blocks reach the bottom of the inclined plane, they will have their kinetic energies in the ratio kinetic energy. Masses m1 by m2 is 2:3. Kinetic energy is half mv square. We have to calculate their kinetic energies. starting initially from rest position. Height is same. From same height they will start incline. So we know B equal to 2gh root over. So height is same. So both cases V1 equal to V2. So kinetic energy Ke1 by Ke2 is half m1 v1 square by half m2 v2 square. Half cancel. v1 equal to v2 cancel. m1 by m2. It's 2 by 3 or 2:3. From option A is our answer. A particle is projected at an angle theta to the horizontal and it attains a maximum height h. This is maximum height h. The time taken by the projected to reach the highest point, let it 1 and 2. From 1 to 2, how much time it take? Let it be v cos theta or vx. Horizontal, vy is vertical, it's v sin theta. So at point 2 we will having only horizontal component v cos theta. Vertical component is 0. Here v cos theta, vertical component is opposite direction v sin theta, and our acceleration is g. So we will use time. We have to calculate from 1 to 2. If we start, v square equal to u plus 2as. In vertical direction, v square at 2 point, vertical a is 0. U square is v square sin square theta minus 2. It's downward acceleration due to gravity, 2gh. H is our height. So we'll get v square sin square theta equal to 2gh. So another v equal to u plus 80. Get v sin theta at point 2. It's 0. Initially it's v sin theta, g downward, so negative, gt. V sin theta equal to gt. This is equation 2. This is equation 1. From equation 1 and 2 we will get v square sin square theta. It's gt square equal to 2gh. So g square g, gt square equal to 2h. So we'll get t square equal to 2h by g, or t equal to 2h by g root over the time. So from option B is our answer. The tension in the cable supporting a lift moving upwards is twice the tension when the lift moves downwards. What is the acceleration of the lift? This is lift. First case it's moving upward, second case it's moving downward. Downward force W, tension T1, tension T2. In this question, the tension in cable supporting lift moving upwards is twice the tension when the lift moves downward. T1 is 2 times of T2. What is the acceleration of the lift? We write equation. Here it's moving upward, it's downward. So for upward movement, T1 minus W is F equal to ma. We will apply W by G A. Question 1. In second case, W minus T2 is W by G A. F equal to ma. Equation 2. From equation 1 and 2, we will get T1 minus W equal to W minus T1 minus W equal to W minus T2. So T1 plus T2 is 2W. From data, its T1 is 2T2 plus T2 is 2W. So T2 is 2 by 3 W. In this question, what is the acceleration of the lift? Let it be equation 3. From 2 and 3, we will get 2 and 3 W minus T2, we get 2 by 3 W equal to W by G A. So W cancel. 3 minus 2 by 3 equal to A by G. So acceleration A is G by 3. From option, it's B is our answer. A screw having coefficient of friction equal to or greater than the tangent of the load angle is known as. A screw having coefficient of friction mu equal or greater than the tangent of the load angle. Greater than equal to tan alpha. It's the case of self-locking screw. The tension in the cable supporting lift moving upwards is twice the tension when the lift moving downwards. What is the acceleration of the lift? Second time asking. So we already discussed this one. Tension T1 2 times of T2 when moving upward, W tension is T2 and given 2 T2 equal to T1 moving downward A. If we solve here, already discussed. In Isro, so many times questions are repeating. So we got question number 22 and question number 18. 2 times asked. B is our answer. Same question with same data. When a jet plane flying at 300 meters per second is at the very top of its trajectory, the apparent weight of a passenger is 1/2 of her actual weight. Find the radius of curvature r of the flight path at this point. Use g equal to 10 meters per second. V equal to 300 meters per second and apparent weight is actual weight by 2/2 of the actual weight. we have to find radius of curvature r. G given 10 meter per second square. So we will use apparent weight plus mv square r centrifugal force equal to W. From here mv square by r centrifugal force, W minus, this is apparent weight. Apparent weight already given here, it's W by 2. So mv square by r equal to W by 2. W is mg by 2, mm cancel, then r equal to 2v square by g. So we'll put the value 2 into v, 300 square, 300 into 300 by 10, it's 33 into 3, 9 into 2, 18 into 10 to the power 3. It's in meter, so in kilometer it's 18 kilometer. From option B is our answer. Thank you friends for watching my video. Thank you.